Wait, this was the one from gave it on Monday?
Yeah.
Okay.
Number 4. Why are y'all not understanding it because you're looking at the solutions?
They have something totally different to A.
I understand how to start.
Okay.
I just don't understand
I don't know what A y'all are talking about. I don't have the solution. Okay, I'm going to do separation of variables. And all that means is get all the x's together on the same side, all the y's together on the same side, right? So to move that over there, I have to divide. So that becomes y to the negative 1 dy equals 2x dx. Yes, no, maybe so? All right. Uh-huh. All right. Here, this is natural log of the absolute value of y, right? Because log can never be negative. You cannot take the log of a negative number. Well, it's going to impact your answer a little bit, and I'll show you why. Equals x squared plus c, right? Okay. Let's plug in the initial condition and find c. Y'all okay with doing that first? Or you can solve it for y first and then do it. Let's plug in the initial condition. All right, so 3 and 0. So the natural log of 3 equals 0 squared plus c. So c is, y'all look at there.
This might be a dumb question, but why is there only one C?
Well, you only need one constant on there because depending on what the constant is we kind of think of it, if you put it here, technically they're different constants, right? And you don't want to do this and have them cancel out altogether. So it doesn't matter what side, because you could have minus c. I mean, it doesn't matter. I always do, yeah. I always put it on the dx. That's general practice, put it on the dx side. All right, so now I have log of y equals x squared plus log 3. Okay, we got to get y by itself.
Square root e, right? Not e, right?
Okay, so you can change the form. You can think about this 2 ways. You can take both sides and let's say e raised to this and e raised to that. Or, and you get the same thing, you can think about it as a change of form. Remember that log? I feel like it might, yeah, still be on the... Because log is log base e. So to get it out of log form, this is really log base e of the absolute value of y equals x squared plus log 3. So to change the form, the base is e, it's raised to all of this, equals the absolute value of y. No. And here's why. If you're in a... Well, if you change forms, remember log base b of a equals x. I can change it to b raised to the x equals a. I can think about it like that. Or I can think about both sides making them the base e and raising them to these exponents, and this cancels. That will always cancel. Yes. Yep. So now, and you do have to know this because of multiple choice. These are typical multiple choice questions where you have to know your log properties, and they show up all the time. If you are adding in the exponent, right, that means this is e squared times e to the natural log of 3. And that's important because e to the log of 3 is 3. Are y'all with me? If this base and this base are ever the same, they cancel and just leave this. Okay, so if it's natural log to the e of whatever, these cancel. If it's e to the natural log of this, those cancel. Okay, so this is 3 e to the x squared
That's how I was doing it, and then I look at solution check and they're pulling an A from somewhere. Well, a capital A. I don't understand what that is.
And they had C and the X.
Well, that's just because they hadn't plugged in. They didn't plug in. Yeah.
Well, and I'm still not done. So y is going to be plus or minus 3 because it's an absolute value. But I have to look at the domain that was specified to start with. So for number 4, there are no domain restrictions, so I would just take this positive root or positive primary solution. Is that not what they got? Yeah, 3x squared. So why are you worried about what they did?
I don't understand where they're getting this A from. I'm fine with
Well, because this is absolute value of y, right? So if the absolute value of, say, 3 could be what's inside, well, actually, the absolute value of x is 3. I could put a negative 3 or a positive 3 in there together. Because there's no domain restrictions in the beginning, so I just take that primary answer, that positive answer. There's nothing that restricts the very first, the 2xy, right? There are no restrictions. I can put positive or negative in there, it doesn't matter. If there were restrictions, you would have to decide if you need the positive. So in other words, if it was no, because I can't have, my y is never going to be able to be negative because, and if the y is negative, that means this is negative, right? Because it's absolute value here. That's right. That's fine. Because at some point in there, you have to take the log of that y, and you'd never be able to make it, right? No, it's because it's the log. Because the integral of y to the negative 1 is natural log. Okay, well, okay, yeah. Okay. So, and that's where you'll get, whenever I did the class where all the teachers were getting certified, every single teacher in there was hung up. I guess I taught Algebra 2 for so long before I went to get certified that I was just breezing through all that. And they're like, how are you doing that? Well, it's not the calculus that's y'all's problem. It's you don't know your algebra because that's the key. So those log properties come up a lot. Okay, 5 is what? Well, let's see. Y equals 1. I would probably separate the variables like they stand. I would do y plus 5 to the negative 1 dy equals x plus 2 dx. And then I would integrate. And if you want to think about this as a u subtype problem, on the left, u is y plus 5, right? So du would be dy. It's kind of a basic u sub problem. Or if you can do it without it, you do not have to. U being y plus 5, du being dy. Okay. So what's it look like? One half plus 2x plus c. I'm going to go ahead and plug in my initial condition. I find it easier to do here than to solve first. And there, if you don't, that's fine too. Y equals 1, x equals 0. If I come up with a positive or negative situation, this is another one where I'm going to have to take the positive because of that absolute value there. All right, natural log of 1 plus 5 equals 0 plus 0 plus c. Log of 6 is c. Okay. Yes. One half x. Well, yes. Same process. Oops, I didn't mean to put. And I'm going to do that. I was just showing every step. I wanted them to see why. But yes, you're exactly right. So y plus 5 equals e to the 1 half x squared, e to the 2x. And there's that 6 there. Yeah. So, and they put it, huh? Well, if I split this up, so I have e to the 1 half x squared plus 2x. I might would leave it like that. I might would leave this plus, yeah. But if you split it, it's not wrong. Then times e to the log 6, and e to the log 6 is just 6. So I just put it in front of it. Yeah. Say that one more time. Yes, division. Say again. So if this was subtraction here, it would be e to the 1 half x squared over e to the 2x. And then I'm going to keep this positive because this needs to stay positive because that does associate with a natural log earlier in the problem. So I'm going to have this 6e to the 1 half x squared plus 2x, and I'm going to just move that 5 over. Because because I'm and there in the beginning when you look at your initial equation, there are no restrictions there for what you can plug in. Maybe if you had an x on the bottom and it couldn't be 0, or maybe if you had a radical that needed to stay positive and so it had to be bigger than a certain number.
We did a tangent of
If you had a tangent where you had undefined values, yes, because there's asymptotes there. You can't be that. You can't divide by 0. Yes. 9 times out of 10, you're just going to take that primary positive answer. Yes. Is that not the answer they got? Yeah. So I don't know what they're doing with A's and their solutions and everything else, but yeah, don't. Just look at the answers. I don't know. I'll have to go back and look at that and see what they're doing because I don't even know.
AP problem is the
6 or 5 first. Okay. So listen, there's a reason I'm not giving you the solutions at this point, and it's the same reason that you're floundering whenever because here's what y'all do. As soon as you look at it, you go, I don't even know where to start. Let me look at the solutions to guide me. And that's okay when we're first learning. That's okay. These will look foreign to start with, and you will struggle with them, and you will flounder, and that's okay. But the more you do, the more they start to look alike, and that's why we're really going to push FRQs to make sure, because they put a lot of gobbledygook in FRQs that just, and you'll see with one of the ones we're doing tonight that it's like things that you don't need that are included in the question, but you have to know how to discern what you need. Okay. So always read through the question completely first. Solutions to the differential equation dy dx equals xy cubed. Also satisfied the second derivative, and then they give you that equation. Let y equals f of x be a particular solution to the differential equation with this initial point. So I see a diff EQ. I see an initial point. So I'm thinking that I'm going to need to solve with that point probably at some time. But I also see a second derivative. Maybe I'm going to integrate to get back to the first, maybe not. I don't know yet, okay? But just recognize what you have. If you want to mark on them, whatever, whenever you get them, you can. But make sure if it's something to be scored, it's in the box to be scored, okay? I did that one time on a practice one whenever I was working with calculus, and I wrote up above it what it was, but I didn't write it down the box to be scored. I'd have lost a point on that. Because I wrote it up here, but I didn't write it down here. No, but I'm just telling you now. I'm just telling you now for future. All right, so part A. Write an equation for the line tangent to the graph y equals, so tan line of y equals f of x at x equals 1. So tell me what I need to write the equation of a tan line. Or what do I need to write the equation of a line, period? A slope and a point, okay? I've got, and actually this says at f of 1 equals 2. I have a point. This is a point on the graph f of x. Do you agree? I need the slope at that point. Well, I have a derivative equation, and we know that derivative means slope at point. So if the derivative is xy cubed, then if I plug this 0.12 in, it will give me the slope at that point. Do we all understand that? We understand why. Okay. So the derivative, which is also the slope, the slope of the tan line is 1 times 2 cubed, which is 8. Now I have a point and I have a slope, and so I just write the equation, point slope form. They like for you to solve it for y. Not that you have to do anything else, but just move that value over, and you're done. That was A. I don't remember the point. I looked up the point breakdown on these, and I can't remember. I really wanted to show y'all. Oh, here it is. Nope, that's not it, is it? What year did I say this was? 2010. Question 6. Just so you see where your point. So that was worth 2 points if you look at the guidelines here. Finding the slope was a point, and then your equation was a point. So that was 2 easy points right off the bat. Remember, it's worth 9. So even though this might have been a hard question, that was 2 points right there. All right, so then part B says, use the tangent line from part A, and this is where I think that if you struggled, this is probably where you struggled. And I did explain this a little bit yesterday, but I'll spend just a little more time, make sure you understand. So it says, use the tangent line from part A to approximate f of 1.1. Given that the function is bigger than 0 on that interval, and the approximation, and it wants you to tell is the approximation greater than or less than f of 1.1, the actual value, explain the reason. So, 2 things I'm asked here. 1, the approximation. 2, is it above, below, or accurate, okay? Well, the approximation is super duper easy because I'm using that, what was it? Let me go back to this one. Right, so if I take this, and this was a calculator problem, right? F is 1.1. 8 times 1.1 minus, you don't even have to show this. You could have just said f of 1.1 equals blah. Plug in 1.1, yeah. What's it come up to be? 2.8. That's a point. Just plugging that in is a point. Your explanation is only worth a point. So even if you didn't understand the explanation or didn't get it, it's only a point out of 9. Make sure you do approximations. Sometimes they will take points off if you put equal whenever it doesn't actually equal. And it did say approximate, so we want to make sure we use those. All right. Well, now explain your reasoning. So is it over, under, or and why? So why? No. You think it's over? It's lower. Let's think about this why. We have a derivative. So the first derivative on this interval from 1 to 1.1, right? The second derivative, the first derivative, is it positive or negative? So we got x, y cubed. It's positive. It's always going to be positive, right? So the function is increasing. And the second derivative, and ironically enough, this is the only reason I was given the second derivative for this whole problem. So it wasn't as bad as what it looked. The second derivative being y to the third times 1 plus 3x squared y squared. Always positive on that interval as well, right? So positive on 1 to 1.1. Okay, so if you plug in 1 here, you're going to get positive, right? 1.0 is anything. You're never going to get a negative number out of this by plugging in a positive value, right? The only way you're going to get that to be a negative, well, this is always going to stay positive and you're adding it, is if this y is a negative number because you're raising it to a negative power, to an odd power, right? And this is always positive. So this is always going to be positive as long as this is positive. Okay, so I'm concave up, I'm increasing, and I'm above the x-axis. So from 1 to 1.1, let's say this is 1 and this is 1.1. In between here, I'm doing something like this, right? If I put a point somewhere on here, let's say here's my 1.1, and I draw this tan line, okay? What you did in the beginning is you used the equation of that red line to estimate a future value. So this tan line was written, it wasn't written at 1.1, it was actually written for 1, but I used it to estimate this value at 1.1. Well, if I use it to estimate this value, it's below the curve right there, right? And in fact, no matter where I go, if I estimate a future point, it's always going to be below the curve. So the value is going to be less than what it actually is. So you can just say this, and you can say, therefore, it's below because of the first and second derivative test. Let's read the scoring guide and see what they say. Conclusion with explanation. So you'll need to say that you would need to show that they're both positive and that it lies below the curve, yeah. But I would say yes if you did all that. For a 1 point here, they just want to they want to know that you understand why. As long as you reference that first and second, those are your keys there, is referencing that first and second derivative test being greater than 0. So that you know the function is increasing and concave up. Part 3 is exactly what we've been doing. It's a separation of variables, and we'll run through that real quick. Find the particular solution, y equals fx. So if it ever gives you a differential equation and it asks you to find the solution, that's where we do separation of variables. So dy dx equals f of x with the initial condition f of 1 equals 2. So what is f of x? F of x is my, or y is my, actually I have to solve for y. All right, so just like we've been doing, separate them. And integrate. Antiderivative of y to the negative third is negative 1/2 y to the negative second. Why is it not natural log this time? That's only when it's negative 1. That's exactly right. When it's negative 1. Otherwise, if it's not negative 1, if it's anything other than negative 1, I can do that exponent property where I just add 1 to it. We can still work with it. There's that c. I like to go ahead and plug in my value to find c, and so I got that initial condition 1, 2. Negative 1/2, 2 to the negative 2, 1/2, 1 squared. This one's a little bit harder than what we've been solving, but it's still doable. 2 to the negative 2 is 1 over 2 squared, right? So 1/4. So what's negative 1/2 times a 4? And again, I'm doing a lot of this in my head or on the paper, but you can use your calculator. This is a calculator problem. So use that to save yourself time. Negative 1/2 plus c. I subtract that 1/2 from both sides. And what do you get?
Wait, so what?
Yeah.
So can you leave it? This is a negative 1. Without doing that for long.
If what's to the negative 1? Whenever I go to take the antiderivative, you'll have to do natural log there if it's negative 1. Well, because, all right, so if you have y to the negative 1, what happens? Your variable goes away. It doesn't work for that one. But your y is gone. All right, so back into my equation. So negative 1/2. I enjoyed this one. Okay. Well, but look, by getting to that point, you've probably gained 3 of the 5 points that this problem is worth. And if you got 2 and 2, that's pretty daggum significant on an FRQ if you can get that many. All right, so why do I keep putting C? Minus 5/8.
So can I just do times -2?
That's exactly what I do. I times -2, so I have y -2 equals negative x squared plus -2 would be what? 5/4? Now, here's what I did. What do you do when you have this exponent and it's negative and you don't know how to get rid of it? That's exactly what I did. I made this into a fraction over here because technically this is a fraction, right? This is a very, very handy skill to have in your box of arsenal. That's what I'm trying to say. I'm going to make this like that so that this is negative 4x squared plus 5 over 4. So they have common denominators because now I'm just going to go whoop on both of them. Flip them over so that my exponent's positive. So I'm going to make this y squared equals 4 over negative 4x squared plus 5. Well, you could. You just have to flip both of them. Can't cancel a 4 because you kill a k. Square top, square to bottom. So 2 over the square root of negative 4x squared. But then you got 1 over y equals, and then you flipped it. Well, and that's the problem. So you could leave them split up like that, but you'd have to remember everything has to flip. Okay, so let's look at the answer. What was mine? Negative X.
Yeah, if you put a 4, yeah.
Yeah, but you got a 1 up top. Something went wrong. I got 2 on top.
Probably because they actually square root everything we selected in that answer for the square root on it.
Oh, they put a 1 over everything.
No, because your final answer is not right. Right? What did you get? Tell me what you got. 1 over the square root of. There's your 2. That I put on the top. I think that's still going to give you the right answer. Yes. Yeah. I did leave out one step. I would have probably missed a point. And I thought about it and didn't do it. Do you see my mistake? Or what I didn't do? Look at that very last part. Because I've got a radical on the bottom, I need to make sure I specify those domain restrictions. That needs to stay positive. So I need to make sure that negative 4x squared plus 5 remains greater than, not greater than or equal to, but greater than 0. Can't be 0 because it's on the bottom. So x squared's got to be bigger than 5 over 4. And then square root. So this is between square root of 5 over 2 and square root of 5 over 2. Because I've got a radical and it's in the bottom. 1, it can't be 0. 2, radical has to stay positive. So anytime you get in a situation where your answer's like that, make sure you specify those domain restrictions there. Okay, so I took the bottom and set it greater than 0. So subtract 5 and divide by 4. This actually switches that way. And then you do the square root, which gives you a positive and a negative value. So you're between the values of positive and negative root 2. Root 5 over 2. That is a lot. I'll help you with it though tomorrow. Yeah, turn in at least where you tried it. So on this one, just quickly, you got a point for knowing that you separate. They always give a point for separation of variables. If you ever see a differential, separate the variables. You always get a point for that. Yeah, I will. For what? The FRQ from last night? Yeah. Okay, I'll make it.
Yeah, you don't get anything if you don't separate it.
If you don't.
Look at that. That's a whole point. That's the plus C. So if you forget the plus C, you're down a point. But if you integrate completely wrong and you've got the constant, there's a point. So if you separate variables and then you know you got a plus C there, you got 2 points out of 5 already.
If you don't get the plus C, you can only get the
Yeah.
So can you solve that with that separated variable? So then it says 1 out of 5 is separation.